Hi everybody. So in this video we're going to talk about shapes of distributions. So we've talked in previous videos about distributions. This is what you can see when you think about the frequency of different data values altogether. And what you would usually do is make a frequency table or a histogram. And what we're going to do in this video is talk about the shapes of those histograms and what they mean. So let's begin with an example. Here we have a histogram, and this is going to illustrate the idea of skew. Histograms can be left skewed, right skewed, or symmetric. This histogram, which is measuring the age at death of Australian males in 2012, is a left skewed histogram. Now, you might think, well, that seems opposite of what I'm seeing here, because the bump on this distribution is shifted off to the right. So why don't we call this right skewed? Well, it turns out what you should be looking at is the tail of the distribution. The tail is going off to the left. So it's as if we had a nice symmetric bump here, and then it got smeared a little bit, some values being smushed more off to the left, and so they call it left skewed. So it might be opposite of what you're thinking. If the bump is off to the right, we call the distribution left skewed. If the bump is off to the left, we call the distribution right skewed. This is an example of a left skewed distribution. And let's think about what that means. I mean, we have age at death, so we know that some Australian males are going to die quite young, right? It just happens. And then as you get old, as the ages increase, it's more likely that we're going to have deaths. And so these bars get taller and taller. And so that means the bump is shifted off to the right, which means we call the distribution left skewed. So this is the type of data that would be left skewed. Let's look at a different kind of skew, right skewed distribution. So here we have household incomes. So this is going to be right skewed because a lot of the incomes are quite low compared to very wealthy families who have incomes that are quite high. But we have fewer of those wealthy families than we do of the lower income families. And so that makes the distribution left skewed. And so what's happening is that we have a preponderance of low values, but we do have larger values that extend off just at lower and lower frequencies as we go to the right. And so this would be an example of a right skewed distribution. Some distributions don't have any skew. And if they don't have any skew, right or left, then we call them symmetric. And that would be an example of, this would be an example of that. So what we have here is the sum of rolls of two six-sided dice. So what we're doing is we're taking two six-sided dice, we're rolling them, and then we're adding the values together. And so you can get any number between 2 and 12. If you roll two ones, you get 2, and if you roll two sixes, you get 12. And that makes this distribution, which is perfectly symmetric. You can see that the likelihood of getting a 6 is just the same as the likelihood of getting an 8. And the likelihood of getting a 5 is just the same as the likelihood of getting a 9. So we get a perfectly symmetric distribution. It doesn't have a skew one way or the other. What are some other shapes that we can talk about? Well, we can talk about how many modes the distribution has. It can be unimodal, means it just has one bump. It can be bimodal, meaning it has two bumps, or it can be multimodal, meaning it has more than two bumps. So this is an example of a unimodal distribution. What are we doing? We're doing 16 coin tosses. We're tossing a coin 16 times, and then what's being measured here, the variable, is the number of heads. So sometimes we toss a coin 16 times and we get no heads. That's very rare, and that's why this bar is so small. Sometimes we toss a coin 16 times and we get 16 heads. We get 16 heads every time, but that's very rare. That's why this bar is very small. The most common number of heads that you'd expect in 16 tosses is 8 heads. And you can see that that happens the most often. It doesn't mean it's a likely event, but it does mean that it happens more often than any other number. And so we can see that the distribution here is it's actually symmetric, and it's also unimodal. It has one bump. what would have more than one bump? Well, here's an example. His is age at first marriage of females. So we have the ages down here, the intervals of different age ranges, and then we have the number of females that got married at that age from this particular sample. And so what we're seeing here is we see one bump over here, and then we're seeing another bump over here, which is making this bimodal. Now, why is this bimodal? Well, one reason that I can think of is maybe how conservative or traditional the family that the person is from is. So if somebody comes from a very traditional family, or if they tend to be more conservative, they might tend to get married at a younger age. Whereas if you come from a less conservative family, or you're less traditional, somebody might wait a little longer before they get married, right? And so we have two kind of types of people here. And because we have two types of people, we have kind of two overlapping distributions. But they're all grouped together, and so we end up getting two bumps. One bump for the one distribution, and then another bump for the other distribution, making this bimodal. And it kind of hints that maybe we could pull this apart and look at those two separate populations individually. Maybe, maybe not. It's something you have to think about with the data at hand. Finally, we could have more than two bumps. And if you have more than two bumps, then we call this multimodal. And this would be a picture of a multimodal distribution. And they've even indicated in here the little tiny distributions that may have been, gone together to make this one multimodal distribution. That could be the case. Not always the case, but sometimes a multimodal distribution comes from having a whole bunch of little distributions put together. And it might be interesting to analyze those individually. But this is all I wanted to say about shapes. So this is it for this video. We talked about skewness, and we talked about modality. So I will see you in the next video.